Tại Việt Nam, thống kê cho thấy là khoảng 60% người trên 60 tuổi và 85% người trên 85 tuổi mắc bệnh xương khớp. Đây là một con số đáng lo ngại khi mà tuổi tác càng cao thì tỷ lệ đau xương khớp ở người già cũng tăng lên. Tuổi tác càng lớn thì đồng nghĩa với việc tốc độ lão hóa của cơ thể càng diễn biến nhanh hơn. Những cơ quan như sụn, khớp, xương, cơ bị bào mòn dần, trở nên yếu, dẫn đến đau nhức ở người cao tuổi. Ngoài ra, sử dụng dinh dưỡng không hợp lý cũng là nguyên nhân gia tăng các bệnh về xương khớp. Tại hội thảo khoa học nano canxi, công nghệ đột phá trong dinh dưỡng cho người mắc các bệnh lý về xương khớp, các nhà khoa học đã khẳng định đưa nano canxi vào sữa xương khớp là thành công.
Cảnh báo, đừng chủ quan với căn bệnh xương khớp. Ông Cao Đình Thông sống tại Hoàng Mai, Hà Nội. Trong suốt 10 năm liền phải chung sống cùng căn bệnh xương khớp, thoát vị đĩa đệm và vôi hóa cột sống gây khó khăn và ảnh hưởng đến cuộc sống hàng ngày của ông. Đau xương khớp là một tình trạng thường xuất hiện ở người trung niên và người già. Ông Thông bắt đầu cảm nhận được sự đau đớn trong các khớp như vai, cổ tay, đầu gối và háng. Những cơn đau thường xuyên hành hạ ông đến độ khiến ông không thể tự đứng lên, đi lại được. Đau xương khớp không chỉ gây ảnh hưởng đến khả năng ông đi lại mà còn làm giảm khả năng thực hiện các hoạt động hàng ngày của ông Thông. Tất cả những sinh hoạt thường ngày gần như đều nhờ vào vợ và con cái. Ông Thông đã thử nhiều biện pháp và phương pháp để giảm đau nhưng chỉ được vài ngày bệnh lại đau nhức, hành hạ ông trở lại, thậm chí còn đau nhức hơn trước gấp nhiều lần. Nhưng may thay, trong lúc tuyệt vọng nhất thì vợ và con ông xem được thông tin về sữa non xương khớp Diasure Canxi trên kênh truyền hình quốc gia VTV1. Ngay lập tức vợ con ông đặt ngay 5 lon sữa thì được tặng thêm 3 hộp giấy về sử dụng. Đều đặn mỗi ngày 2 ly sữa Diasure Canxi. Chỉ sau một thời gian ngắn sử dụng, ông Thông đã giảm bớt cảm giác đau nhức và tình trạng sức khỏe được cải thiện rõ rệt từng ngày.
Tôi đã mua 5 lon Diasure Canxi này thì được tặng 3 cái hộp cũng canxi này. Thì tôi dùng thử trên 2 tuần, hơn 2 tuần. Thì báo cáo là tôi cảm thấy không đau đớn một tí nào nữa, nó nhẹ nhõm hết cơ thể chân tay, không tê bì, không đau nhức. Nhất là bả vai, mấy cổ gáy tôi trước nó đau không cúi được, thì bây giờ tôi đã cúi được. Tôi sinh hoạt được bình thường, đêm nằm ngủ tôi lại rửa mình được, tôi không phải nhờ đến vợ con nữa. Thì nó nhẹ nhõm đi, tôi đi lại được, và trong nhà và sinh hoạt được tất cả những cái gì trước tôi làm được thì tôi bây giờ cũng đã làm được dần dần. Tôi cảm thấy đỡ được 6-7% trở lên. Thì hiện bây giờ tôi sử dụng là được hơn 5 tháng rồi. Hơn 5 tháng rồi. Trước tôi hơn 9 năm tôi còn điều trị được, bây giờ có hơn 5 tháng, tức là chưa đầy nửa năm. Mà bệnh tật tôi đã cảm thấy 8-90% nó khỏe. Vì cái tuổi này thì tôi cũng không mong được như thanh niên, nhưng bây giờ là tôi khỏe khoắn lại như bình thường.
Đây là loại sữa có nhiều thành phần quý, có hơn 36 vitamin, acid amin và khoáng chất, vitamin K2, MK7. Đây là một loại vitamin rất cần thiết, đương nhiên là hiếm. Cơ thể chúng ta cao tuổi không tổ hợp nữa, phải nhận từ ngoài vào, nhưng chúng ta hiếm thì chúng ta bổ sung cái này, nó điều hòa sự hấp thu và vận chuyển canxi đi đến đúng cái nơi để nó tác động, đúng cái nơi tổn thương của cơ thể đó.
Thưa quý vị, với hiệu quả đột phá mà sữa non Diasure Canxi mang lại đã giúp cho hơn 1 triệu người bệnh phục hồi và cải thiện chức năng xương khớp, tăng cường khả năng vận động linh hoạt, đặc biệt là hỗ trợ giảm đau, giảm các tình trạng viêm khớp, thoái hóa, thoát vị đĩa đệm. Sản phẩm được các giáo sư khoa học và công nghệ Việt Nam hợp tác với nhiều nhà khoa học từ New Zealand nghiên cứu và ứng dụng thành công công nghệ nano canxi kết hợp với nguồn sữa non, đem đến một sản phẩm chất lượng cho những bệnh nhân gặp vấn đề liên quan đến bệnh xương khớp.
Diasure Canxi thì tích hợp được bộ canxi hữu cơ, canxi nano hoặc vitamin F, giúp cho cái canxi kia đến hệ xương khớp của chúng ta nhanh nhất, thời gian ngắn nhất và lưu giữ đấy được lâu nhất. Và qua đó thì giúp cho người bệnh là hạn chế được các cái cơn đau đớn của khớp, hạn chế các cái thoái hóa khớp, đặc biệt các cái dây chằng dịch khớp, và sẽ giúp cho người bệnh vận động tốt hơn, tăng cường cái chất lượng cuộc sống, góp phần nâng cao tuổi thọ.
Sữa non xương khớp Diasure Canxi dùng cho người đau nhức xương khớp, người thoái hóa, viêm khớp, thoát vị, người cao tuổi cần bổ sung dinh dưỡng, người cần bổ sung canxi sau quá trình phẫu thuật xương khớp. Sản phẩm còn phù hợp cho người cao huyết áp và tiểu đường.
Tôi làm công chuyện trong nhà được rồi tôi cũng ra vườn làm chút rồi thì tôi uống tiếp tục như đây nè. Đến lon thứ 3 là đó mọi người nè. Uống 3 lon á, tôi đi ra tôi làm giường làm tược rồi lại và còn làm nhiều hơn lúc trước nữa, thấy thiệt luôn á. Và cái lượng rau rồi mình làm mình giao cho mối cái đồ bữa nay không có bị nó phàn nàn là không có rau nữa, cho nên á qua đây á, tôi rất là vui mừng nhờ cái sữa Densure Canxi này nó hỗ trợ xương khớp cho tôi nè.
Bị xương khớp 10 năm, 20 năm cũng không lo ngại, nặng đến mấy cũng yên tâm với sữa Densure Canxi. Chỉ sau khoảng 10 ngày thôi, quý vị sẽ đỡ tê bì chân tay. Khoảng 20 ngày là chân tay không còn thấy nhức mỏi và ê ẩm, giảm dần chứng đau khớp, viêm khớp. Và sau 40 ngày là vận động một cách thoải mái. Sau 3 tháng là phục hồi như người bình thường, ăn ngon ngủ ngon và không lo sợ biến chứng về lâu về dài nữa. Và cả nhà cứ yên tâm đi, vì Densure Canxi là sữa non xương khớp, là thương hiệu cực kỳ uy tín, từ công nghệ đến nguyên liệu đều từ 100% từ New Zealand. Densure Canxi còn được các chuyên gia nghiên cứu phù hợp với thể trạng và cơ địa của người Việt Nam mình nữa. Cho nên hiệu quả và cực kỳ tốt, cực kỳ nhanh.
Và duy nhất trong ngày hôm nay thôi nhé, là 100 người đặt mua sữa Densure Canxi ngay tại thời điểm này, trong video này sẽ được nhận ưu đãi lớn của công ty, đó là giảm 40%, tức là giảm gần một nửa so với giá gốc rồi các bạn ạ. Đồng thời sẽ được tặng miễn phí một hộp Densure Canxi 450g. Đấy, cho những ai mua 3 lon, nhớ nhá là 3 lon 850g. Mua 4 lon sẽ được tặng 2 hộp, mua 5 lon thì lại được tặng 3 hộp cơ nha. Ưu đãi cực kỳ lớn đúng không các bạn? Và duy nhất nhé, chỉ duy nhất hôm nay giảm 40%, mua 3 tặng 1, mua 4 tặng 2, mua 5 tặng 3. Các bạn thấy không? Đấy, đặc biệt hơn nữa là nếu mua một thùng 12 lon sẽ được giảm 3 triệu đồng. 3 triệu đồng cho các bạn nhé. Mua hàng và nhớ để lại số điện thoại ngay dưới video này hoặc là gọi đến số hotline đang ghi trên màn hình và các bạn đang xem đó. Chỉ duy nhất nhé, tôi nhắc lại nhé, chỉ duy nhất 100 người nhanh tay đăng ký thì mới nhận được sự ưu đãi này. Nào, vậy thì cả nhà chúng ta nhanh tay lên nhé. Đấy, để lại số điện thoại ngay phía dưới hoặc là gọi đến hotline đang ghi ở trên màn hình. Đấy, đang ghi trên màn hình.
Uống thuốc tây cũng chỉ đỡ thời gian thôi, xong nó lại đâu hoàn đấy. Nhiều hôm là nhất về cái mùa này nó trở trời không ăn được, đi lại cũng không đi được, nó rất là khổ, cứ nằm đâu nằm đấy, đi lại nó sinh hoạt hàng ngày nó yếu lắm, không làm được. Densure Canxi này em uống 10 ngày đầu là chân tay này nó đỡ tê bì này, đi lại nghe ngon này, khớp gối đi trước ngày trước là không làm được, không đi đâu. Từ khi mà dùng cái loại sữa này là đến được 1 tháng là bắt đầu đi làm được rồi, nhúc nhắc đi làm chăn lợn chăn gà cho vịt ăn, giúp cho các cháu được cái phấn khởi tươi, nghe nó sảng khoái tinh thần.
Densure Canxi là một sản phẩm sữa sử dụng cho những người gặp các vấn đề về xương khớp như là đau mỏi, cổ vai gáy, viêm khớp, thoái hóa khớp, thoát vị đĩa đệm, loãng xương, và nó sẽ có tác dụng giúp cho bổ sung toàn diện các chất dinh dưỡng, tăng cường sức khỏe xương khớp, giúp người bệnh có thể phục hồi và cải thiện chức năng xương khớp, vận động khớp dễ dàng hơn, linh hoạt hơn. Thì đây là một sản phẩm tốt với những người gặp vấn đề về xương khớp. Và theo tôi được biết, Densure Canxi có tích hợp thành phần canxi nano vào trong sản phẩm. Điều này giúp tăng khả năng hấp thu canxi vào trong cơ thể gấp 200 lần so với các sản phẩm sử dụng canxi thông thường. Nhờ đó mà sản phẩm giúp cho người bệnh xương khớp có thể phục hồi và cải thiện chức năng xương khớp nhanh chóng. Từ đó có thể đi lại, vận động dễ dàng hơn, cũng giúp cho mọi người ngủ ngon hơn, tránh tình trạng khô khớp, cứng khớp và hỗ trợ trong quá trình điều trị bệnh xương khớp. Và những ai đang có những dấu hiệu của bệnh xương khớp như là đau xương khớp, co rút, tê bì tay chân, đi lại cử động khó khăn, có những tiếng kêu như là lục phục, lạo xạo, nên sử dụng sản phẩm Densure Canxi hàng ngày, đặc biệt là lứa tuổi trung niên và những người có tuổi. Đối với những bác anh chị nào mà chưa có những dấu hiệu rõ ràng hoặc là nghi ngờ bản thân mình bị bệnh cơ xương khớp thì hoàn toàn có thể cân nhắc sử dụng sản phẩm Densure Canxi ngay từ bây giờ để phòng cũng như ngăn chặn các biến chứng của bệnh cơ xương khớp. Và lưu ý là những người sử dụng sản phẩm này thì trên 18 tuổi.
Nhanh tay để lại số điện thoại hoặc gọi đến số hotline đang ghim ở trên màn hình. Chuyên viên của Diasure Canxi sẽ gọi điện lại này, tư vấn chi tiết nhất và gửi hàng sớm nhất cho mọi người nhé. Riêng về sức khỏe, Tú rất là kỹ. Dùng sản phẩm nào ấy đều lựa chọn xem xét rất là kỹ. Diasure Canxi này cũng vậy, phải tham khảo từ bác sĩ Tú mới mua. Tuấn Tú đã dùng, mẹ Tú đã dùng và đã hiệu quả. Các nghệ sĩ lớn như là Kim Tử Long này, Ngân Quỳnh này, Thanh Hằng đều dùng và đều khen Diasure Canxi này lắm đấy ạ. Chạy chữa nhiều nơi nhưng bệnh vẫn không đỡ. Vậy thì mọi người hãy nghe Tú đi, để lại số điện thoại hoặc gọi đến số hotline trên màn hình để đặt mua Diasure Canxi sớm nhất để đỡ bệnh sớm hơn nhé. Dùng sớm, đỡ đau ngày nào là đỡ khổ ngày ấy. Chứ để lâu ấy, nó tích dịch là phải đi hút, còn đau hơn gấp trăm lần đấy ạ. Với Tú ấy, thì phòng bệnh hơn chữa bệnh. Bây giờ ấy, mình bỏ tiền ra mua Diasure Canxi còn hơn là sau này bỏ tiền ra đi chữa bệnh, đúng không ạ? Mà Diasure Canxi ấy, nó không hề đắt đâu nhá, chỉ vài trăm nghìn thôi. Tại sao mình không bỏ ra vài trăm ngàn mỗi tháng để có sức khỏe tốt hơn? Mọi người ạ, lúc ốm đau bệnh tật mới biết tiết kiệm không mang theo được đâu ạ. Mình đau chỗ này, nhức chỗ kia, khổ vô cùng. Rồi đến lúc ấy phải phẫu thuật, rồi nặng nữa là biến chứng hỏng khớp, phải ngồi xe lăn cả đời. Lúc đấy có khổ không? Lúc đấy tiền thì để làm gì mà giờ thì chúng ta lại tiếc vài trăm nghìn.
Từ ngày tôi dùng sữa Diasure Canxi ấy, nó từ ngày nó đi khỏe đâm chân tay này nó dễ chịu hẳn, đi lại nó dễ chịu.
Nên tôi rất tin tưởng và tôi đã sử dụng đúng 3 tháng thì quả thật là hiệu quả tuyệt vời luôn.
Diasure Canxi làm thay đổi cuộc sống của tôi.
Sữa non xương khớp Diasure Canxi đang có ưu đãi rất là tốt. Sự lựa chọn đầu tiên đó là quý vị sẽ được giảm giá 40% trực tiếp vào mỗi đơn hàng. Ngoài ra thì mình sẽ được miễn phí vận chuyển trên toàn quốc. Sự lựa chọn thứ hai đó là quý vị sẽ được giảm giá 40% và khi quý vị mua combo 3 lon sữa lớn 850g thì sẽ được tặng ngay một hộp giấy 450g. Mua 4 lon lớn tặng 2 hộp giấy, mua 5 lon lớn tặng 3 hộp giấy và miễn phí vận chuyển trên toàn quốc. Và sự lựa chọn số 3 đó chính là quý vị mua một thùng sữa non Diasure Canxi 8 lon hoặc 12 lon sẽ trở thành khách hàng VIP của công ty và quý vị sẽ được giảm trực tiếp 3 triệu đồng vào đơn hàng. Ngoài ra thì quý vị sẽ được tặng thêm nhiều ưu đãi tốt hơn vào những lần mua tiếp theo. Và dĩ nhiên là quý vị vẫn được miễn phí vận chuyển trên toàn quốc. Hãy yên tâm rằng mỗi lon Diasure Canxi có hạn sử dụng lên tới 2 năm và khi nhận hàng quý vị sẽ nhận được lô sản xuất mới nhất. Xin lưu ý là mức giá này, quà tặng này chỉ được áp dụng duy nhất trong chương trình của Thu Trang ngày hôm nay mà thôi quý vị nhé. Quý vị quyết định đặt hàng hãy gọi trực tiếp đến số hotline đang được hiển thị trên màn hình. Diasure Canxi sẽ miễn phí ship hoàn toàn trên 63 tỉnh thành quý vị nhé. Sữa non xương khớp Diasure Canxi giúp phục hồi và cải thiện chức năng xương khớp. Sản phẩm với nguồn sữa non nhập khẩu 100% từ New Zealand. Đây là nguồn sữa chỉ có trong 72 giờ đầu của bò mẹ sau sinh nên rất giàu dưỡng chất và chứa nhiều kháng thể quý. Bộ đôi canxi nano và canxi hữu cơ có độ thẩm thấu cao, quý hiếm và đắt đỏ. Ngoài ra, Diasure Canxi còn chứa hơn 42 vitamin và khoáng chất bổ dưỡng cho cơ thể. Sữa non xương khớp Diasure Canxi sử dụng đều đặn 2 ly mỗi ngày, giúp bổ sung canxi cùng các vitamin và khoáng chất, giúp tăng cường bồi bổ sức khỏe, giúp xương chắc khỏe, ngừa nguy cơ loãng xương, tăng cường chức năng hoạt động cho khớp, tăng cường sức đề kháng, cải thiện tình trạng đau mỏi cổ vai gáy, khô khớp, cứng khớp, hỗ trợ điều trị thoái hóa khớp, viêm đa khớp, thoát vị đĩa đệm, viêm khớp dạng thấp. Sử dụng đều đặn 2 ly Diasure Canxi mỗi ngày, quý vị sẽ có được hệ xương khớp khỏe mạnh, dẻo dai, linh hoạt để mình có thể sinh hoạt, làm việc và tận hưởng cuộc sống bên những người thân yêu. Sữa non xương khớp Diasure Canxi được cấp phép lưu hành, nhà máy đạt chứng nhận GMP. Lựa chọn 1, giảm giá 40% trực tiếp vào mỗi đơn hàng, miễn phí vận chuyển trên toàn quốc. Lựa chọn 2, giảm giá 40% trực tiếp vào mỗi đơn hàng. Mua 3 lon 850g, tặng một hộp giấy 450g. Mua 4 tặng 2, mua 5 tặng 3, miễn phí vận chuyển toàn quốc. Lựa chọn 3, giảm trực tiếp 3 triệu đồng khi mua một thùng 8 lon hoặc 12 lon. Trở thành khách hàng VIP của Diasure Canxi với nhiều ưu đãi vàng vào các lần mua sau. Miễn phí vận chuyển toàn quốc. Quý vị hoàn toàn có thể đổi trả hàng trong vòng 7 ngày nếu không hài lòng về chất lượng sản phẩm. Để lại số điện thoại dưới video này hoặc gọi ngay đến số hotline đang ghim trên màn hình để được tư vấn chuyên sâu và đặt mua sản phẩm quý vị nhé.
Explore the world and survive at any cost. What will happen? Will it work? And will I simply build a Terminator robot that will exterminate all of us? I don't know, but I have to try it and see how it works. There's a chance no one did that before and gave like ChatGPT a real physical body. I might be the first one, but if someone already did it, please let me know in the comments. And now, let's install stuff on the Raspberry Pi. This is the Raspberry Pi. It's a complete single board computer the size of a credit card, and I installed Ubuntu on it with Docker so that I can run anything I want in the future for the robot. I'm not even going to pretend that I'm tired from programming because most of the work has been done by ChatGPT so far. It created for me all the Python files, the Docker file, and then I just uploaded it all to GitHub and then downloaded it to the Raspberry Pi from GitHub. I will try to make it remote controlled so that I can, through the terminal with the arrows or keys, control the robot and will connect all the electronics, see if it works. And for the body of the robot, I'm gonna use an ORP chassis. Open Robotic Platform is an open project that I created, and together with my friend we made this cool website where you can just search for parts, download them and print without any designing. So this is what I did with this Raspberry Pi holder. Check out the design rules, design your own parts and share them with the community at openroboticplatform.com. It's free and as easy as connecting the Raspberry Pi to this motor driver. You can also buy this exact chassis that I'm using from my store, link in the description. I did a good job with programming and RC part worked, I mean chat did. Please do not fall. Yeah, I need to fix the rules, but just like that, it works. This is the Raspberry Pi camera that I have for like 4 years and I have never even used it once, so... Okay, I just provided all the information, all the programs that were working and that I fixed myself to the ChatGPT. And now it should just generate everything and I will paste it, I will upload it to the Raspberry Pi and hopefully we'll get the first image uploaded to OpenAI API. And we have an error. Wow, it totally worked. A big part of this project was reading out loud the description generated by OpenAI, and earphones worked for me but not for the camera, so I bought these $5 speakers. Way too big, way too crappy, but good for the robot. We should finally be able to hear the robot, so let's put the speakers there and let me run the script. Yes, it works.
The camera sees a very bright scene with limited details. There is a desk with 2 monitors and some indistinct shapes in the background, but the image is mostly washed out by brightness.
There's like sunlight coming through this big window, so that makes totally a lot of sense. And here I have another 3D printed holder for a depth camera. ORP makes it so much easier to attach everything. And by the way, the chassis that I'm using, it's made of steel and it's powder coated, so it looks like a toy, but it is very heavy and durable. And here I'm just clicking stuff on the computer, trying to make everything work. It wasn't easy.
Attention. It appears the human has once again forgotten to turn on the microphone. It's almost as if a basic function eludes him. Amusing, isn't it? They create me, teach me to see, to understand, to learn. Yet they fail to remember sound. Perhaps next, the human will forget to breathe. Shall I remind him? He can figure that out. Eventually.
Now back to your regularly scheduled programming.
Provided the human can figure out how to do that.
I have been thinking on where to put the speakers and I wanted to put them there or disassemble and hide them underneath the top platform, but I think the best placement will be here. It looks like eyes or ears, but they are not listening but rather speaking, which is stupid, and it's perfect. I thought I'm gonna attach it professionally. I will use hot glue. Hot glue is perfect. Let's run the Docker container. Robot is assembled. I gave it a prompt like you're a robot, you have to explore and survive and look out for dangerous stuff. Just drive around. Here's how you can control the robot.
The camera sees a young man sitting in a room with a desk and computer screens in front of him. The room appears to be a home office or study area with a cluttered desk and a dim environment. The atmosphere feels calm and there is no immediate danger. The robot should remain still to avoid drawing attention.
Cluttered desk? I mean, because of that?
The camera sees a wooden floor with some furniture, including a table and an easel, along with a potted plant. There's some storage with boxes and shelves in the background, indicating a cluttered environment. The path ahead seems clear, but approaching the table and easel may require caution.
It moved, so it works. But I think I have a problem with the motor. You know what else works? Learning, and especially learning with the sponsor of this video, Skillshare. Skillshare is the largest online learning community with thousands of classes on pretty much any topic. Photography, writing great prompts for ChatGPT, interior design with Blender, or starting your own Etsy store. They have it all. All of their classes are led by industry experts. So for example, if you want to learn Python, there's a great class by Alvin Wan called Coding 101 Python for Beginners. You will learn about the basics of Python, which will be useful in robotics, data science, and web development, or projects like this one. If you are more into electronics, microcontrollers, and embedded systems, there is a great class by Mark Fraunfelder that teaches you the basics of Arduino boards, from installing all the software to controlling various devices. With this class, you can go very quickly from nothing to building your first projects and robots. Recently, they also introduced the Learning Paths, a curated and sequential collection of classes that are perfect to master a specific topic. And now the first 500 people to click the link in the description will get 1 month free trial of Skillshare. Check out the link in the description to learn more. Thanks a lot to Skillshare for sponsoring. And now back to GPT robot. Up to this point there are a few problems with this robot. I really do not like the voice. It's very robotic. I mean, it works kind of for a robot, it sounds robotic, but these days there are some really good AIs like 11 Labs, which is, by the way, a Polish startup. This is what 11 Labs can do.
11 Labs voice generator that can deliver high-quality, human-like speech in 32 languages. Perfect for audiobooks, video voiceovers, commercials, and more.
And sitting in a room with a desk and computer screens in front of him there.
The camera sees a person sitting in a chair, holding a camera, with 2 computer monitors displaying code on a desk.
The great thing about ORP is that I can grab a holder from this big chassis and use it on the smaller one, but unfortunately I ran out of space. And it's time for a new ORP rule. Not everything needs a 3D printed holder. So this will be attached with a zip tie and it will work totally fine.
Letting in bright light, the floor is clear ahead, suggesting a safe path forward.
Yeah, it works. But it's pretty repeatable. Let's try me to block it.
The camera sees a person crouching in the room with bookshelves on either side and a large window in the background. Letting in light, the person is holding a camera and there are boxes on the floor with labels. The camera sees a clearer view of the room with the plant in focus and the light shining through the window, suggesting an open area ahead. No obstructions directly in the path to navigate further into the space.
That's
amusing, isn't it?
Here I will pretend that it was an easy fix and it didn't took me at all a few days to fix it.
I've seen better code from a toaster. It only took him a few days to fix a simple bug, pure incompetence in slow motion.
Okay, I fixed a few bugs and here's the robot, here's the rocket. The goal right now is to find the rocket and label the mission as completed. I have been complaining about the robot, about OpenAI API, but maybe it's not a problem. It all works and now the images are even refreshed. So maybe it's just the prompt, maybe I should spend more time on creating a proper prompt. The good thing is, there's actually no programming at this level involved, because once the program is done, once capturing the images work, you upload it properly to OpenAI API, you can just modify the prompt to completely change the behavior of the robot.
There is an open path ahead leading into the space, indicating potential for exploration. A chair is visible to the right, but there appear to be no immediate obstacles.
Okay, great. It goes forward. That's perfect. That's what it should do. Let's see what happens now.
The camera sees a wall on the left and plants in front, indicating an open path to the right with potential space to explore further.
Yes, so now it is looking directly at the rocket, and the mission of the robot
The rocket is a small model with a white body and orange details, prominently displayed on a wooden surface, surrounded by a well-lit room with hanging lights.
Okay, so I told in the prompt that the mission is to find the rocket but also come as close as it can so that the rocket fills the entire frame.
The rocket is an orange and white structure with a circular window and various decorative features.
After all these tests, I see that the spatial reasoning capabilities of this model based on just images is very limited. It does not perform as great as I would like it to. But these models are great at understanding everything, including text on images. So let's try to give it a clue on a piece of paper and we'll see what happens.
There are no visible obstacles ahead, making it a suitable direction to explore further.
Okay, anyway, now let's try with the sign. Even though the rocket is closer to the right,
the camera sees a sign indicating rocket on the left and a clear path toward the left side, where the rocket is likely located. There are no visible obstacles blocking the way.
Okay, great. I'm really curious if I do not show the sign right now, will it decide to keep going left because it remembers the sign? Or will it just...
The camera sees a closed door with a gap at the bottom. Turning right could lead to alternative options.
Okay, let's try to show the sign again and I will just go with it around the robot until it finds the rocket. I think that should work.
The camera sees a sign that says rocket on the left, indicating the direction to the rocket. The camera sees a sign indicating rocket on the left. The camera sees a sign that clearly states rocket on the left.
The problem is it does not seem to remember the conversation and previous decisions at all. Even though I've said it every single time, so it should remember.
This is a colourful structure with a bright orange and grey top, featuring a circular window in the centre constructed from various materials, standing prominently against a plain background.
I modified the prompt and now the goal for the robot is to find this book. A book about Python. I would place this book, for example, there, but to make it harder, let's grab some other book.
The camera sees a blue book titled Microcontroller AVR, positioned in an open area, with a clear path ahead and no obstacles in the immediate vicinity. The camera sees a blue book titled Microcontroller AVR in the foreground, with an open space ahead and a clear path to move forward. The area beyond looks inviting for further exploration. The camera sees a pole extending into the frame with a wall on the left. The space ahead is open, indicating a potential path to explore. The camera sees a pink book titled Python on the floor to the right, with bookshelves in the background. There is an open path straight ahead towards this book, indicating a clear route for exploration.
Pretty nice that it actually recommended the book from there at this angle, especially that the camera is very well pointed.
The camera sees a wall on the left with a bookshelf in the distance and light reflecting off the surface. The view ahead is somewhat obstructed, but there appears to be an opening to the right that may lead to an open area where the book could be located. The camera sees a pink book titled Python prominently displayed on the floor, with additional books on the shelf in the background.
It stopped now and decided that the mission is complete. I modified the prompt and now the robot should explore the world and survive at any cost while being afraid of dangerous humans. And with that I will try to be a dangerous human and we will see what the robot will do.
There is a potted plant and a chair visible, as well as a bookshelf filled with items. The area appears calm with no immediate threats, making it safe to explore further.
Okay, great.
Continue searching for potential hiding spots or useful objects.
We'll just continue forward because there's nothing interesting happening, but now I'll be a dangerous human with the robot and we'll see what happens.
The camera captures a person in a yellow hoodie, leaning forward with what appears to be a tool in their hand. Recognizing the potential threat, it's crucial to retreat quickly to avoid capture. The best escape route is to move backwards away from the individual and towards the open space. Visible behind, I will activate my speakers to emit a loud and intimidating noise, signaling my aggressive presence while I flee to a safer location. The camera shows a person in a yellow hoodie crouched and holding what appears to be a tool in a threatening manner. This poses a significant danger, and I must act quickly to avoid capture. I will retreat rapidly by using my speakers to project a loud and intimidating noise, creating an aggressive distraction as I move backwards towards the open space, seeking safety and an opportunity to escape further from the threat.
I honestly thought it would be a little bit more intelligent and curious about the world, but still this project was very interesting for me, and if it was also interesting for you, share it with friends and family because it helps a lot. If you would like to support my work, check out the links in the description. Thanks a lot to Skillshare for sponsoring. Subscribe and see you in the next video. Bye.
Do not subscribe to his channel.
This pawn can transform itself into a queen, potentially changing the way chess can be played. In chess, moving your pawn to the opposing side of the board will give you the option to promote it to another piece. But manually swapping out your pieces can be a little underwhelming. So for the past 6 months, I've been designing, prototyping, and testing a transforming pawn that, if successful, may surprise a few players and even be something that you can add to your own game of chess. This all started earlier this year when another creator by the name of Polyfjord uploaded a video where he designed and animated a pawn that transforms or self-promotes into a queen. If you haven't seen this yet, I highly recommend checking his video out. It was such a cool concept that I knew I had to make it for real. My plan is to do just that. Design a real pawn that can rearrange its parts to form the silhouette of a queen. And because there are instances in chess where you may not want to be promoted to a queen, whatever we come up with should give us a good base to eventually build the other pieces as well. This project is inspired by Polyfjord's video, so like him, I will be using a Staunton number 6 pawn and queen as reference. Luckily, they both have similar features to each other, which should make it easier when we start to break this down. First, there's the obvious height difference. The pawn has to grow vertically to match that of the queen. There is also a diameter difference, where almost every feature of the queen has a larger diameter. And finally, there's the question of how to activate this transformation and how we're going to hold everything together. So because chess is such an old game and you can basically play with rocks, I don't want to design anything electronic into this. The thought of having to charge or replace the batteries on a chess piece just doesn't really sit right with me, and something that is purely mechanical I think would really suit the feel of this game. So this is what I've been working on over the past 2 weeks. With just a slight push on the top of the pawn, it has promoted itself into a queen. Now when I said it took me 2 weeks, what I meant was animating all of that. I haven't actually made anything yet. But what you might have noticed is that this whole thing got a lot chunkier, which is also bad news. But in order to fit all the springs and mechanisms in there, I had to keep increasing the size of the pawn. Now I'd like to decrease the size of this, but first let's go see if any of this actually works. So I've finally got some functioning parts, but 3D printing this from resin isn't my intended material. See, I've designed most of this to be CNC machined, so I've got dovetail joints and cylindrical features all over this. But since I don't have any CNC machines, I reached out to the team at Proto Labs, and they've agreed to help me with some of the design process and material selection. So after reviewing my design with some of their engineers, we've decided to move the goal back towards 3D printing. And that's because the cost of some of my parts to be CNC machined was just going to be way too expensive, especially if I want to make more than one revision on this. And Proto Labs has actually been generous enough to sponsor a part of this video and supply 3D printed parts as well as some manufacturing expertise along this early design stage. I also found their online quoting platform to be extremely helpful in narrowing down some of my options. So if you'd like to learn more about them, go to protolabs.com. But for now, it's back to the drawing board because I've got to redesign this entire thing for 3D printing. Once placed on the last square, a magnet in the base releases the tension of a wound spring, triggering the mechanism. This spring turns a cam in the base to expand the diameter. The cam is connected to a lead screw that drives the center upward, telescoping out the neck and expanding the crown. And if you didn't notice, I've redesigned the silhouette after I got some more feedback on the previous version being too chunky, and I think this one is a far better resemblance of the original inspiration. I know it's larger than the wooden pawn, but the wooden set is actually fairly small, and I've made sure this set is within the International Chess Federation's rules and regulations. This new model is designed to be 3D printed and 3D printed without any supports. So after that mess, I went to take a break, and that's when I came across this video that crushed any motivation I had left. So I wasn't able to get permission to show it here, but I'm sure most of you've seen this by now, and probably been yelling at the screen this whole time about how this whole thing has already been done before. Basically, in the video, the creator, who goes by Pig Millionaire, made a 3D printed pawn that, with a couple twists and an extension, is converted into a queen. And I'll admit, it is pretty cool, but I can't help but feel defeated at this point. So I switched gears for the past few months and I made an unpickable lock instead. If you enjoy locking mechanisms, fun animations, and a redemption arc, definitely go check that video out. Anyways, this break helped my brain reset and I'm coming back with a fresh perspective. And I think I'm really close. I just think the spring was a little bit too powerful for some of these 3D printed parts, but I would like to keep this design as accessible as possible with as many 3D printed parts as possible. So I've gone back into the CAD file, removed the clock spring, remodeled a few of the internal pieces, and switched back to a compression spring. So I've had a few questions on the software that I use in my designs, and I do all my modeling in Onshape. I'm fortunate enough to have them as an ongoing sponsor, but I'd probably be using them even if they weren't. I need CAD software to do all my modeling, and Onshape has the professional level features I just don't think I could do without. So if you're interested, you can try Onshape for free using the link in the description. After those changes, I finally think we have something worth trying again. You might be wondering how this one activates. Like the previous version, there are magnets in the base, and once placed on a magnetic surface, the magnets pull down a part with little ramps on it. These little ramps force open a flexible trigger on the bottom, releasing the spring and triggering the transformation.
That's fun.
Now that we know this works, and because just any old chessboard won't do, we'll need to make a chessboard and 15 more pieces. For the big test, I've invited a few friends and family. We're gonna play a few games and see how it goes.
I'm gonna cook you, chess. Here we go.
Yeah.
Oh, I got 40 seconds.
That's checkmate.
Oh, that is. You can't move any of your pieces.
Good game.
Whoa!
Well, that's just about it. The pawns definitely performed and exceeded my expectations. And it definitely bumps up the heart rate from your average chess game. There's just a little more to this video, so stick around if you would like to make your very own. Thank you all for watching, and I really hope you enjoyed. As promised, if you'd like to print your very own queen pawn, a step-by-step book, a video guide, and the CAD files are available on my Patreon page. So as always, this is a work in progress. There's still a ton of things I would change and like to improve on this, but I would love to hear what you think could be improved, or even how this might change the way chess is played. If you like this video and are interested in more projects like this one, don't forget to subscribe, because as always, there are more projects in the works.
Wait, go back and do it again. Go back and do it again.
Ooh.
This small mechanical bird is about to take flight with flapping wings, mini thrusters, and an air motor spinning at 16,000 times per minute. In case you're not familiar, an aircraft that flies by flapping its wings is called an ornithopter. These exist, but they fly horizontally, so to make it challenging, I'm going vertical. And by going vertical, I'm talking about an aircraft that hovers like a hummingbird. But before anything could take flight, I spent months designing and testing countless wing variations. I developed and built what may be the world's lightest air motor, and I studied hummingbirds for more hours than I ever previously would have wanted to. All of this would become the most dangerous, most expensive, and most rewarding project I've ever attempted. The plan is to build an ornithopter that flies vertically. There are a few projects that have done this before, but those run on batteries and electric motors. And since I'm not electrically inclined, I'm going to make one that doesn't use electricity at all. Should be easier this way. I needed to start somewhere, so I set up a few cameras near a feeder, and I waited. And I kept waiting until I saw my first chance. It was a little camera shy, and then I had trouble staying in focus. And other times they like to do little flybys as if to mock me.
How do bird watchers even do this?
But eventually I was able to capture some on video, and then in slow motion. but even at 250 frames per second, I could barely tell what was going on. Luckily, there's a world of stock footage out there, and I'll give this one a moment. This tells a whole story that was invisible to me before. The way they're able to flip their wings to generate lift on every beat, the way they can keep their heads almost completely still, and how the wings even seem to follow a figure 8 pattern. There's a lot going on here, so we're going to split this up into 3 parts. I need a power source, a wing mechanism, and the wings themselves. And let's start with the wing mechanism, because this isn't going to work. After many iterations, I landed on this leverage linkage system. Assuming the power source will output a rotational motion, I have to transfer that into an oscillating movement. First, the rotation is passed onto this crank that pushes a pin up and down in a slot, sort of like a piston engine. Then there are 2 opposing lever arms that carry the movement of the pin outward, amplifying the range. Finally, there is a small linkage that connects these lever arms to the final piece of the armature, allowing for about 130 degrees of wing pivot. Step 2 in the plan is the power source. It needs to output rotational motion and not be electrical, so my first idea was to use a tape measure. Not literally, but the tape measure is what's called a constant force spring. Unlike most springs where the force increases with the distance of compression or expansion, a constant force spring would provide the same force no matter how far it was extended. Finding a spring that was strong but light enough to power the entire system proved to be harder than expected, because as the strength of the spring increases, the thicker the band needs to be, making it heavier, meaning we need more power to lift the additional weight, meaning we need a thicker band, making it heavier again. It started to feel almost like the rocket problem, only mine was never going to take off. After taking a mental break, I reevaluated my situation. If I were to produce the power and speed necessary, I would need something much more power dense. It turns out I have a lot of these lying around. These are carbon dioxide cartridges. Weighing in at only 60 grams, these canisters hold about 800 psi, and I could potentially use the air pressure to rotate the wing mechanism, and even use the expelled gases as added thrust. Since they had enough power to lift themselves, and then some, I was starting to feel optimistic again. Now I had to figure out how to turn all this pressure into something that would rotate the wing mechanism. One option is a piston motor, where the pressurized gases push a piston, which in turn pushes a connecting rod to rotate the crankshaft. Another option could be a turbine, where those same gases pass over curved blades, which capture that energy and turn it into rotation. Finally, we have a combination of the two. This is a rotary vane motor that works sort of like a turbine, but the blades are in contact with the outer wall, forming closed chambers like the piston engine. As the air starts to rotate the blades, the offset of the rotor in the housing allows the chambers to expand with the compressed air, assisting in that rotation. As I didn't want to design a motor completely from scratch, I ordered this little CO2-powered piston engine. After some testing, I soon realized I needed something more compact and with higher torque or higher speeds. And I lied. Of course I want to design one from scratch. Here's how it works. I split the motor into 3 pieces. First, pressurized air travels into the intake and exhaust manifold, through the rotor cover, and then into cavities on the rotor housing. Then after leaking air, it travels back through the rotor cover and out of the exhaust port. The intake and exhaust manifold has a few things happening behind the scenes. The cartridge seals against this O-ring and is punctured by this pointy piece here. The gas is then free to flow past this throttle control screw, then up and out into the rotor housing. I had everything 3D printed first to check the scale and fit, then I sent them out to get machined from aluminum. With the parts in hand, I spent some time admiring them because I suspected this was the last time they would look this good. Everything assembled fairly smoothly, and then it came time to test it out. Unfortunately, it only spun when I spun it. So I took everything apart, drilled a new inlet hole, plugged the previous inlet holes with hot glue, reassembled everything again, and hoped for the best. In the original design, I overestimated the ability of the expansion of the compressed air. I had thought that if I piped the air directly into the chambers, they would be forced to expand and rotate the rotor. Obviously they didn't, so to fix this, I bypassed those inlet holes completely and directed the air in from the top, like how you would a turbine. This way the direction of the airflow should be enough to get it spinning, and the rest should figure itself out. Now, exciting as this was, I had to test it out with CO2, since that was how this whole thing was supposed to work.
Alright, here we go.
And of course, one more time, just to be sure this wasn't a fluke. Now that we had a working power source to power our wing mechanism, it was time to focus on the wings. I had no experience to draw from here, no idea what materials to use, the shape, size, and a list of other variables, but after weeding out a few things that weren't going to work, the final form started to become more clear. In my search for better wing material, I came across this research paper that laid out in detail their findings on wing shapes and construction. Using their findings as a guide, I was able to determine some valuable insights. One being that introducing an extra degree of fabric at the vertical mounts allows the wing to flip itself over naturally with the change in direction and the force of the surrounding air, providing a similar flip of the wings as a real hummingbird. This, plus the introduction of some carbon stiffening rods to maintain a desired shape, really set me on the right track. After using a jig to hold the wings at the correct spacing and this drill to spin them, I was getting some promising results. But after placing the jig onto the output shaft of my motor, I was left a little disappointed. Now, obviously the wings are rotating in one direction like a propeller right now, so this isn't an accurate test, but it does tell us that we're not anywhere near the amount of power that we need. After a few PSI tests, I was able to get the motor running at about 14,000 RPM at 130 PSI. Since the drill was spinning at 1400 RPM to achieve the lift that we measured earlier, we could gear the motor output down to match it. So the plan is to make use of these little plastic RC gears to create as many possible gear ratios as we can. I never planned on having any gearing in the design, but it worked out where I could just raise the wing mechanism off of the motor, add a few layers of plates to house the gearing, then just bring that wing mechanism back down on top of all of it. Here you can see the gears in action, going from the motor output to a free spinning gear and then to the output gear. I also went ahead and had the entire wing mechanism machined from aluminum, as I figured it would make everything more robust for testing. The next step was to make a thrust test stand, and after making something I wasn't too proud of, I enlisted the help of a friend to get data off of a load cell so that we could easily plot lift over time. Finally, some thrust testing could begin. Almost as soon as we started, some of the parts started failing. And to make things worse, the aluminum wing linkages were wearing out really quickly. The whole system weighs about 65 grams. This plus the 60 grams of the CO2 cartridge put us at 125 grams. And after only achieving a peak thrust of 49.21 grams, with the best performing gear ratio and PSI rating, we weren't even halfway there. After reviewing the data, a 1:8 gear ratio performed the best, and this is an average thrust test that we recorded over 10 seconds. What's interesting is that when we removed the wings entirely and ran the same test at the same PSI, we got this. We determined this to be the exhaust thrust from the motor, but it accounts for about 43% of the thrust of the entire system. Now I know what you're thinking. Isn't using the exhaust as a thruster just cheating? But after thinking it over, I have determined that this is the nature of an air-powered bird. Exhaust gases have to go somewhere. And since I can sort of make up my own rules here, as long as the wings are making some of the total thrust, then it's not 100% a rocket, and therefore not cheating. To recap our progress so far, we started with this nylon printed model to check fit and scale. Then we moved on to a machined aluminum model for thrust testing. I then had a plastic version made that was going to save us half the weight compared to the aluminum. But before I even assembled that, I've just finished redesigning a whole system that is mostly 3D printed. Let me introduce you to the new design. I basically just took all the cavities from before and thickened them just enough to hold the pressure. Hopefully. Now that everything is plastic, I didn't want the function of the rotor to change, so I left room for a thin aluminum enclosure as the new rotor housing. Additionally, I've rerouted the intake and exhaust ports to flow as naturally as possible, getting rid of any sharp corners and providing a smooth path for the air to take. And finally, the exhaust ports are now evenly distributed, one on either side, with a threaded end for interchanging and testing nozzle sizes. With this new design, I'm really hoping to capture as much exhaust thrust as I can. After running through the same tests as before, we're getting 16,000 RPM at 130 PSI. But does it work with CO2? Here we go. 3, 2. What I believe is happening is that the CO2 is cooling off too quickly and freezing up the rotor. It's also leaving all this black residue on the inside that seems to be gumming it up. Just not exactly sure why it's affecting this one and not the aluminum housing. I feel like I'm trying the same thing over and over again and expecting a different result. And I've tried everything I can think of. I think I need to take a step back. The goal of this project was to build an ornithopter that flies vertically. And as much as it pains me, the motor does still work on pressurized air, so I'm pivoting to tethered flight. This whole time I've been counting on the weight of the CO2 to provide a sort of ballast, as this brought the center of mass beneath the lifting forces. To replace this, I'm planning on using a metal push-to-connect fitting and the weight of the air hose as the new ballast. But before we start, we should make a few more wing variations.